serves as a review of what we learned for logarithms. So we're going to work with this stuff first, and from here we'll run through, I think, the basic parts of this, and then we'll do some review. Okay, so I'm going to give you some basic examples of these properties that you want to know. So on 6.5, you want to make sure that you know how to do exponential form to log form. Let me just give you an example. Say, for instance, you have the logarithm base 2 of, say, 8 is equal to 3. That's an exponential form, or I'm sorry, that's a log form. How do you change this problem that I gave you to exponential form? You need to know that on next week's test. What do you say? 2 to the third equals 8. Good. Okay, so that's really the fundamental part about logarithms. You've got to know how to change those things back and forth from one form to another. Okay, the next property is a log of any base of 1 is equal to 0. Now I'm going to give you an example of each one. Just write it down. Let's say you had log base 3 of 1. Okay, the reason it's equal to 0 is, how would you write that in exponential form? You would say 3 to the 0 equals 1, right? And that's true, of course. Anything to the 0 power is equal to 1. So you want to remember that the log of 1 of any base is always going to be 0. Okay, I think this one has a mistake in it. I mean, it says lob. It should say logarithm, of course. So that's logarithm base b of b to the x equals x. Okay, again, a lot of these properties you don't have to memorize. It's just that, you can figure them out as you go if you understand logarithms well. So let's write down this example. Let's say you have log base 4 of 4 to the third. Okay, well, according to this property, the answer would be that exponent 3. Okay, so let me explain why that is. Okay, this is something you probably should write down on here. I'm going to just do the side where I have room. So if you had the log base 4 of 4 to the third, the way you would work this out, and you wouldn't have to know this property, the property is just a time saver, you could set that equal to x. Now if you wrote that in exponential form, you would say 4 to the x power is equal to 4 to the third. Okay? Now if you look at what I just wrote down, what does x have to be in that equation right there? It can only be one thing. What is that? 3. Okay, if the bases are the same, so are the exponents. We've talked about that, so x has to be 3. So what you would encounter, if you encounter this, like if you had, say, log base 7 of 7 to the 10th, the answer is 10. Okay, now the key thing is, these things have to match up. If that's a base 7 and that's a base 7, then that's the answer to the problem right there. You're probably going to forget that property, so you want to have a strategy to figure it out. And the key to that is being able to do stuff in exponential form. Okay, next one, you will see this if you're going to go like to Calculus 2. A lot of times when I teach Calculus 2, it seems like this property right here shows up all the time. Students, by the time they get to that, they usually have forgotten that property, but really get it solid when they're in a calculus class. So let's do an example on this. Let's just say that you had, say, 11 to the log base 11 of 10. Okay, according to this, if this is in the exponent, if your exponent has a logarithm, and the key thing is these things have to match up, then the answer is just this thing right here. I'll show you why in just a minute. So that's a real simple thing that shows up a lot in higher math here and there. Okay, here's why it's true. I'd like you to write this down. Let's just write down log base b of x equals log base b of x. This is where this property comes from. And sometimes this is confusing when I do this to students who've never seen this. You could actually write this equation in exponential form. Both of those are the same thing, so obviously that's true, right? Okay, but how would you write this in exponential form? You always say this to this power equals that number. And if you do that, you will get that property. So if you say b to this power equals x, that's what that property says. See if this makes any sense to you. So what I'm going to do is I'm going to write this down. That's the base. Okay, then to this power, log base b of x power is equal to x like that. Does that make sense what I did? Tell me. I don't know. Sometimes students don't seem like they catch that very well. Okay, so the idea is if you go back to problem number 2, that's easier for students to see. 3 to the 0 equals 1, right? You got that? This is the same thing. I did the same thing. I said this to this power equals that. Same thing. This to this power equals x. It just looks weird, okay, but it's the same exact thing. So that's where that property comes from, okay? So that property shows up a little bit. Next one, I'm not going to really do a derivation of this or anything. I'll just give you an example. So it turns out if you have a logarithm, and let's say you had something like the logarithm of 2 of 8 times 4, okay, anytime you do a log of a product of two numbers, it turns out that you can write this as the sum of those two logs. So you could do log base 2 of 8 plus log base 2 of 4 when you break that up, okay? And it doesn't matter as long as those two logs, log of 8 and log of 4, exist, then you can break it up like this, okay? So I'm going to show you, this is a good example to show you why it works. So if you did the log base 2, 8 times 4 is 32. Now for next week's test, this is something you want to be able to do pretty easily. Okay, what do you raise 2 to get 32? And you might not know that immediately, but you could reason it out. How many times do you multiply 2 out to get 32? That's my question. 5, good. So 2 to the 5th is 32, right? So this logarithm right here would be 5. Now do this. Do this in your head. You want to do that quickly. What do you raise 2 to get 8? 3. How about here? What do you raise 2 to get 4? So 3 plus 2 is 5. That's what I want you to see on that example. Yeah, so this would just be 3 there. That would be 2 there. So 3 plus 2 is 5. Now that's why it works. That doesn't prove anything. It just shows you a demonstration of one example that it works, but it always does work. Okay. The next one's pretty similar. An example of this would be if you have a log of a quotient, you can write it as the difference of the two logs. Okay, so I'll make up an example on this, see if I can come up with something on this. So let's say we have log base 2, and let's say we have something like 16 over 8, something like that. Okay, according to this property, what you do is you can write it as the log base 2 of the top, 16, and then subtract the log base 2 of 8. Okay, so that's different than property 5 where you're adding the logs. In this case, you subtract the logs. So let's see if this makes sense to us. Okay, let's go over here first of all. I want to make sure you guys can do these in your head pretty quick. What would be the answer to this? 2 to what power is 16? 4. Okay, how about this one? 2 to what power is 8? 3. So you have 4 there, you have 3 there. Okay, all right, so that's going to be 3. No, 4. I said 4. Okay, so that's going to be 4. This one's going to be 3. Now, if you work out this side, see, this is really log base 2 of 2 because 16 over 8 is 2, right? So what is this? What power of 2 is 2? 1. 2 to the first is 2, right? So you're going to end up with 2. 2 to the first equals 2. So this side would be 1. This side would be 4 minus 3, so it worked, didn't it? That's what I want you to see. Tell me if that makes sense what I did. Okay, because you guys for next week's exam wanted to be able to do the basic logs. These properties were going to be things that you're going to get into a little bit more on your final, but it's kind of good to go ahead and get those things down now. Okay, this one right here, you're going to use this a lot. When we get into next week and kind of learning what we're going to learn next Wednesday, you'll use this property a lot. So I'll just give you a basic example. Say you had something like log base 8 of any number. It doesn't even matter what that number is. You could have 10 to the second power. Well, it turns out that what you can do is anytime you have an exponent, you can bring that down in front of the log. So that's 2 times log base 8 of 10. Okay? Now, with these kind of problems, I'm not going to derive this one or anything. I'm just going to show you, and then we'll be working with this a little bit more next week. One more example, you can write down if you want to, if you had an ln's a log. If you had x to the third power, well, then what you can do is you can bring that 3 down and multiply it by the log. That's a very powerful rule we use all the time. When we teach calculus, do certain things with limits and stuff, we do that all the time. It's very common. In financial applications in finance, that's property. It shows up all the time. Okay. What this one is saying is it's just saying you can take a log of both sides. So if you had a mathematical equation, like if you had x plus 1 equals 10. Okay, well, obviously you know the answer to that problem is 9, but this really says you can take a log of both sides of an equation just like you're used to doing anyway. It also says you can take the log off of a side of an equation. So if you were trying to solve an equation like log of x squared equals log of 9, then what you would do is just take the logs off. You're not canceling off, but you would just take them off and then you would solve the equation. So that just says that you can take a log of both sides or you can remove a log from both sides of the equation. Okay, that's the idea. That's what those properties are saying. Okay, so when we work out these logs, some of these kind of things, I'll kind of talk about the ones that you need to already know from what I've taught you, and then the ones that are a little bit newer to us. Okay, what we're doing on this is we're just looking at properties. Okay, so if you look at this one, if you look at property number 2 said if you do a log of 1, you always get 0. So the answer to this problem is 0, okay, and that's by property 2. It's a good idea to just write down what the property is, okay? All right, now, more than likely you're going to forget that property, and it doesn't matter if you forget that property because the way you would work this out is what I've already shown you, and this is something I expect you for next week's test. You could set that equal to x. If it's a natural logarithm, what is the base? E. So you could say e to the x is equal to 1. Well, what does x have to be? E to what power is 1? 0. Okay, so you reason that out. You want to be able to reason that out, okay? All right. The next problem is kind of the same thing, okay? We had a property up here, I think, that said, well, actually, we don't have a property on that one. You could have a property for this one, but let's just do this the same way. Set that equal to x. How would that go in exponential form? 3 to the x equals 3. Okay, if you can't do that, if you can't change that to exponential form, you can't do anything with a logarithm hardly. So what does x have to be in this problem? It has to be 1, good, because 3 to the first is 3, therefore the answer to that problem is 1. Okay, like that. There's a property that says that, but you don't have to know that property. Okay, the next one, if you look at the properties I gave you, this one is the same thing as property number 3. Okay, so you might want to write what these properties are as you go, because if you learn these properties, then you can do these problems real easily. Property number 3 said that if you have a log base b of b to the x, then that exponent is the answer. So what's the answer to this problem? 3. Okay, according to that property, that answer is 3. Now again, these things have to match. That 9 and 9, if they're different, then that probably doesn't work anymore. So those two bases got to be the same. Typically, what a student's going to do is a student's going to forget this. So what I would recommend you do, and we need to do this too, because this is fair game for next week's exam, even though you don't know this property, although I don't care if you use the property, you would set it equal to x. Now, how does this thing go in exponential form? You'd say what? 9 to the x power equals that whole thing, right? Then that gives you the ability to figure it out. So you'd say 9 to the x equals this whole thing. Well, what does x have to be in that equation? 3. See what I mean? So you can figure most of these things out, and the best way to learn most of these things is to be able to figure them out instead of just memorize a bunch of properties, okay? Okay, the next one. This one is property 4. Okay, so property 4 on this one says, property 4, the way I wrote that out is I had b to the log base b of x power equals x. So what's the answer to this problem based on that property I wrote down? 10. Okay, good. The answer is 10. Okay, all right. That one's probably one that you want to just know. It's a little bit harder to figure that one out. That one's kind of good to get yourself introduced to in college algebra. If you're going to go through calculus, trust me, you'll see it all the time. Particularly in Calc 2, it seems like it shows up all the time. But not so much until then, just from my experience. Okay, let's go to the next page here, because I mainly want to just kind of work out some properties and kind of get you going on some of this stuff here today. So if you look at the property, go ahead, please.
What was example 4, the property for example 4?
Example 4 was property 4. Yeah, property 4. If you look back a page on that, that has the same kind of structure. Okay, so that's property 4. Okay. Okay, now this one, example 5, if you go back and look at the property 5, this is what this one's going to belong to. Okay, and I'll show you how this one works out. It's a good idea to write the properties down just in your notes. So property 5, and what property 5 said was this. I wrote property 5 down like this. Log base b of mn is equal to log base b of m plus log base b of n. Okay, so what I've done is I've given you the right-hand side of this property. So if you see two logs of the same base, they have to be the same base, being added, then you can just write it as one log with the 9 times 4 being multiplied. Okay, so the way to do this problem would be like this. You would end up just having that this is equal to log base 6 of 9 times 4. So that's log base 6 of 36. Okay, that's how you put that together. Now for next week's exam, I definitely want you to know how to do that in your head. What's the answer to this log? 2. Why? Because 6 to the second is equal to 36. The answer to a log is an exponent. 6 to the second is equal to 36. Therefore, that's equal to 2. Okay? Now the next problem is the same property. This one is still property 5. And what you're going to be doing with this is do this. Okay, you have a log of a product. Anytime you have a log of m times n, two things multiplied, then you can say the log base 3 of 9 plus the log base 3 of 27, like that. Okay, then from here, this is the kind of stuff you want to be able to know for next week. What's the answer to this log in your head? 2. How about this one? 3. So what's the answer to the whole problem? 2 plus 3 is 5, right? Okay. All right, so that's kind of designed so you can do that in your head. So that's 2, 3 to the second's 9, 3 to the third is 27, so that's equal to 5. Okay, so that's how that one would have to go together then, all right? Okay, and again, in order to do this, you got to have multiplication right there. You have multiplication of two numbers, you can break it up into the sum of two logs, okay? Okay, the next one. Okay, if you look at the exponent, you're still going to use property 5 on this. You're going to use more than one property on this, but if you look at property number 5, that says if you have two logs of the same base added, then how do you put those two logs into one log? You multiply. Remember how we did that first one there? So you're going to say log base 3 of 6 times 7, right? Okay. So you would put this one together like this, and say 5 raised to the log base 5 of 6 times 7, which is 42. Okay, now that's 5 log base 5 of 42. Okay, now we had a property number 4 on the first page of your handout that says if you have b to the log base b of x, the answer is x. So what's the answer to this problem after we put it together? 42, good. Okay, so that has that same structure, and again, these two things have to match up in order for that to happen. So that's how that would go, all right? Okay, so once you're past next Monday's exam and everything and start doing homework on this, try to get your properties down as you're doing your homework. Use properties when you need to, otherwise try to figure them out without the properties, because that's the best way to learn most of this stuff anyway to me. Okay, this one right here is, let's just see if we can figure this one out without a property. Okay, so let's write this. First of all, an ln is a log base e, right? So it's a good idea to just write that as log base e of e to the square root of 3. Okay, let's just totally forget about properties on this problem. If you don't know a property or don't know how to figure out a log, I always say do the same thing. Set the thing equal to x, then write it in exponential form. So what's the exponential form of this problem? E to the x equals e to the square root of 3. Right, good. Okay, that's always the same. This to this power is equal to that. Once you get that down, then most of the time you're going to have the power to figure this out. Okay, looking at what we have, what does x have to be? Square root of 3. Okay, yeah, definitely. So that's it. Okay. All right. So let's go down and do some problems, these next 6 problems here. And then I'm going to probably show you a little bit with change of base. So that's as far as I'm going to go with this section. I wanted to get through about the main half of this section. So we're going to go down to about page 4, and then the rest of this we'll do like next Wednesday. So go ahead and I'll give you a little time to do these problems and see if you can do these okay. And you look at your notes, you can look at your properties. You can try to figure them out without the properties if you feel like you can. Okay, but partially you're trying to learn your properties on this. And then we can focus on reviewing for the test so we can have a good review. Number 1, you know what the answer is? That's the one, if you know the property, then boom, you know the answer. It's 10, good. Okay, that one's 10. Okay, if you didn't know the property, then you would just do log base 3, 3 to the 10 equals x, and then write it in exponential form to get 3 to the x equals 3 to the 10th. Okay, that's the way I do it because I don't remember the property most of the time. The next one's also automatic, according really to the same property. You know what the answer to this is? Negative 11. Yeah, this one is saying, really, if you have an ln, that's log base e of e to the negative 11. Again, if these bases match, then that's your answer right there. Okay? If you didn't know the answer to this problem based on the property, then you would just do that. Set it equal to x, write it in exponential form. You'd have e to the x equals e to the negative 11, and then x has to be negative 11, right? Because you're going to do that all the time, okay? How about number 3? What'd you get? 15. Yeah, that's one of the properties, okay? 15, okay? That's 15, okay? That one's one you just probably need to know the property on. Okay, how do you put number 4 together? If you have 2 logs added, how do you put it into 1 log? You do what to those numbers? 8 and 8 and 8. You multiply, right? Okay, so what you do is your first step is you would do log base 4 of 8 times 8. So that would be log base 4 of 64. Now what's the answer in your head? 3, good, because 4 to the 3rd is equal to 64. Okay, so that's how that goes, okay? All right. Okay, next problem is a whole lot like the one I just did. If you have a log of a product, how do you break it up into 2 logs? What do you do? Log of a product, 2 logs, what do you do? You add, good, thank you. Okay, so that one you would say log base 5 of 5 plus log base 5 of 125, like that. That's how you would start the problem. Now you're back to the kind of stuff we've been working on. So what is the log base 5 of 5 in your head? 1, because 5 to the first is 5. What's the log base 5 of 125? 3. 5 to the 3rd equals 125. Therefore, the answer to the problem is 4. Okay? All right? Okay? Now, the next one, I did a problem like this. How do you put these 2 logs right there together? The key is you have 2 logs subtracted. So how do you do that? What'd you say? Divide, thank you. Okay, good. So you would say 3 log base 3 of 5 over 4. Okay, it goes like that. Now, if you know the property, the answer is staring you right in the face. Do you know what it is? 5 over 4, right. Okay, anytime you have a number to a power, and if the power has a logarithm in it of the same base, then that's your answer right there. Okay, so that's it. Okay, all right. So those things aren't too hard to do once you kind of get your properties down, and a lot of them you can figure out without the properties. Let's go ahead and finish up this page, and then we can start with our review. So I want to show you what we call the change of base formula, and this would be, one thing you want to do is get your calculator. First of all, if you got your calculator with you, just get that out, and we'll run through these together. Most of the calculators, now some of the more modern calculators have got somewhere in the calculator a way where you can do a log of about any base you want to. On the standard calculators, you have a base 10 log, your log, and you have a base e. So if you wanted to do log base 5 of 20, you couldn't do that unless your calculator has a place in it, which most of the time I don't even like to tell the students, because I like you to learn the change of base formula, okay? You can look it up if you want to, if your calculator does it. But what I want to teach you how to do is how to do the change of base formula. So what you do is you just do this. You can do this first problem. You can do the log of 20 and then divide that by the log of 5. So you do the log of the 20 divided by the log of the base. Or it works if you do ln. It doesn't matter which of those logs you do. And then from there, you just do it on your calculator. So you can do this on your calculator with me if you want to. So pick your key. Okay, I'm going to do log 20 on this one, close parentheses, and then I'm going to divide by log of 5 like that. And then you'll get a bunch of decimals on this. So you'll end up getting, for this, I will just round this, 1.861, 353,116. You could round that up to whatever you wanted to. So if I said round to like 4 decimals, that would be 1.8614 like that. So that's how you do that. Change of base formula is real simple to do. It allows you to do a log of any base. Okay? And then the next one, same way. You pick which one, log or ln. Let's just do ln on this one. So we'd do ln of square root of 2 over ln of pi. And you would want to use your pi key. You wouldn't want to use 3.14. Just put all the decimals in your calculator. So we have ln square root of 2. Okay, like that. And you want to make sure you close parentheses around that then. And then just do ln and then pi. And again, it's up to you whether you use log or ln. They both always give the same answer. So you're going to end up getting with this 0.30275577807. And if you wanted to round it, let's say we want to round it to 3 decimals, then you would have 0.303 like that then. Okay? All right, that's real easy to do. This kind of thing, I can think of some situations like in a Calculus 1 class when you start learning about derivatives of logarithmic functions. It's real beneficial to know this rule because it keeps you from having to remember some other rule. That's the way I like to think of that. So that's something that pops up in higher math some. Okay, next problem. We're going to do this. Now you have a log base 3 and you have a log base 8. Now this one could be possible to do without the calculator. I kind of have a suspicion, but we're going to find out. So let's do this first of all. Let's just do an ln. Most of the time I'm going to use ln. So we'll say ln of 8 over ln of 3 like that. Okay. Then do the second one. We're going to write that as ln of 9 divided by ln of 8 like that. All right. Now what do you see happening? The ln of 8's cross out, don't they? Those are a number. Ln of 8 is a number, so it can divide out like if you're reducing fractions. So that would leave me with ln of 9 over ln of 3. Now, yeah, you could go to your calculator, but I'm going to do this without the calculator. I'll show you what happens. Okay, notice 9 and 3 have something in common. What do you think is a good idea to do with the 9, just out of curiosity? What'd you say?
Make it divisible. It's divisible by 3.
Yeah, you could do 3 to the second, or 3 times 3, okay? So you could do ln of 3 to the second times ln of 3 over ln of 3 like that. Now I showed you a property. We hadn't really done it much here, but one thing you can do anytime you have a log of a number to a power, there's a property that's on your first page that says that 2 can come down, so you'd have 2 times ln of 3 over ln 3. What's the answer to this problem? 2. Good. Those things cross out, so that's your answer to your problem. So I didn't have to touch my calculator. You could, and I promise you if you did, you would have got 2 anyway, see? Okay? So sometimes you can use the properties to simplify your logarithmic expressions fairly well then, okay? Okay, well let me close this off. That takes us about where I want